day after back surgery. Need to be up and around a bit, so out digging around in the garage. Got this thing on, right? It's running on the batteries. I think the pulsation and the kilovolt output from the Sprink device is actually a result of the inverter, because it's pulsing pretty good over on the inverter, so it must be the draw that's being pulled on the batteries that's causing that pulsation. Which means I probably could fix that if I added some very large, a couple of farad caps over the 12 volt feed into that battery bank, or into the inverter from the battery bank. But I got a couple. I'm not doing that yet. I'm playing with the collection aspects. All right, so the Sprink is on. 2 meters like this in series. Alright, 60,000 volts DC is what's floating on the system. Kind of see the pip balls doing a little wiggle, but not much. I chucked that shorted loop up in there. The bottom's negative, top's positive. And then I got a little full wave volt quadrupler as the Tate ambient collector kind of thing going on right here. So these are 10,000 PF or 10 NF, 3 kilovolt caps. They're not quite sized right because my driving side is 1650 PF roughly, which would be 1.65 NF. So I need to actually have just a couple of 3300 PF caps in series to get close to that 1600, and that'll replace those 2 caps over here. And then on this side it'll look the same with the 4 caps, but they'll be the same 3300, so 1650 on the left side of the collector and 1650 on the right of the collector. The center lead is the common ground, right? This thing is the common ground here. It's a very fine filament that shows. It's a lot thicker if I run a conductor from here to, say, this chair, which is touching the concrete, but I'm wearing sandals. Actually, it's the day after back surgery, so I'm wearing my compression stockings still. Microdiscectomy on L2, L3. But I need to be up and about so I don't generate blood clots, and I thought the high voltage would help my recovery speed along. These are the outputs that would go into like a capacitor as the final collection from the full wave volt quadrupler, right? And so these are charged. Left side here is positive. So maybe you can see the filaments here. Not really, huh? Can't get it to focus with it. Let's see. Pulling a charge, but it's not very well coupled. If this thing was grounded, this would charge more rapidly. And the reason it's discharging when I touch it like this, on the one side, on the negative side, it causes that other side to charge up even more. Because I'm adding to the oscillatory current that's being input into this via insulated screwdriver. But I don't think you can see that. Filament. It's a tiny filament. There's too much crap in the background for the camera to focus on. Anyway, it's charging up, so I need to get this size right. I need it to be 1.6 NF here, 1.6 NF there, and then 1.6 NF on both legs, feeding off of that the antenna side. And the antenna side is just about, I don't know, whatever that gap is from there to there. It's probably about 6 or 8 inches. the antenna side. Seems like the screwdriver's a little magnet. It's magnetized the charge because it's causing that wire to wiggle. Anyway, the point is to get this thing sized appropriately so it charges some capacities, and then I can build 4 or 5 of these things and just, stick them at appropriate gap length. As long as they're pulling in at least 16 volts, which obviously they are, they're generating the spark, right? Once they're pulling in 16 volts, then I can run that 16 volts back into the drive. Because this is what's powering it. This is a 12 volt bank. These are 2.6 volts or something, 6 of them in series. To make the 12 volts, and it's 1500 amp hours per battery, and that's a 6 kilowatt inverter. And what's actually being drawn right now, this is what's being drawn to generate the Sprink device. I can't bend over it, you can see. Alright, so that's the current input. We're looking at about 4 amps. So about 12.5 volts. So it's not too much to replace. And then once we collect in it, we'll see how much we can collect. And then we'll just generate pulsing via periodicity, right? You got 5 or 6 collectors, pulse each one in sequence back into the charge battery. So it's getting delivered a constant string of charge, but it's not requiring each of those capacitors to charge up instantaneously. And we'll size that appropriately once we get to that point.